Alright guys, now we're going to take a look at the ultrasonic level sensor. So this is an additional unit that you can purchase for the lab volt process control station. It sits on top of the tank, and it gives you an awesome accurate 4 to 20 milliamps out or 0 to 10 volts out based on the level that's in the tank. We're going to look at this guy and we're going to have a 4 to 20 milliamp DC output signal, and that's going to correspond to the tank level of from 10 to 50 centimeters.
Alright guys, so this is our setup here. So this is your standard station here. Previously we've looked at the level of the tank by putting a DP cell here at the base of the tank and looking at the pressure that developed at the base of the tank. This was good, but it was accurate, but it wasn't deadly accurate. So now what we're going to do is we're going to use an ultrasonic sensor that's mounted at the top of the tank. This guy is going to punch an ultrasonic sound wave down, bounce off the top of our water column, and then come back. It's going to look at the transit time between the time that it goes out and comes back, and it sends a signal back over onto this conductor here. And with this guy, it has a setup here where you provide it with 24 volts, and it gives you 4 to 20 out. And we have to set this guy up to match with whichever level points we have in our tank. So we're going to set up a lower level and a higher level, and this guy is going to give us a deadly accurate 4 to 20 milliamps out based on those 2 points and any value in between.
Alright guys, so first thing we need to do is push that continue there. That's going to bring us up to this page. Then you go to process, work with the process control trainer. Okay, continue again. And the next thing we need to do is go to setup. Scroll down to enable communications. And now we're talking to the unit. We should be able to see those LEDs chirping at us.
Excellent. So we're trying to connect up to this I/O interface, and now that we've enabled those communications, you should see these 2 LEDs chirping at you at the top of the unit. So we have the transmit and receive LEDs chirping at us, and now we're talking to this bad boy right here. And now we can talk to the rest of the unit. This is our input-output interface.
Okay, so what we just did is spelled out right here in these 7 steps. Double click on the LV ProSim icon, go to process, go to work with the process control trainer, press continue, go to setup drop down, click on enable communication, and then you should see the RX and TX LEDs chirping at you like we just saw. Excellent. So we are now moving on to this portion. So now we've got to look at the wiring of our I/O interface that we just started communicating with, and going from the I/O interface over to the pump. I need a lead going from number 1 on the I/O interface. So you can see right here, I need a lead going from here over to, sorry for making dizzy. I got to go from there over to the pump. And on the pump, I've got to go to the 0 to 5 input. And then to close that circuit, I need to go from common on the I/O interface over to common of the pump. Once you've got that done, then that will allow the 0 to 5, so you can see here on the actual I/O interface, these guys are going to be punching out 0 to 5 volts DC. So that will allow our 0 to 5 volt signal to go to the pump, and now we can control the speed of the pump. Excellent. Once you're done that, then move on to this, and we're going to hook up everything based off this fairly crude P&ID diagram. So with this one, we're going to have the supply going to a fill valve. So this is just a ball valve. That going to the base of the tank. The other connection to the base of the tank is going to go into another ball valve. That's going to go back to our tank or our pump. And then at the top, we're going to close off this connection right here. And we're going to have a longer tube that goes from the top of the tank and goes and vents out to atmosphere. That way, if this guy starts to overflow, then this tube right here is going to act as our overflow. Let's go take a look in the lab and see what it looks like.
Okay, so let's start here. There's our I/O interface, and I've got a lead coming out of my analog output, and I've got one coming out of my common, and those guys are just coming over here, and they're tying into my pump, right? They're tying into these guys right here, where I've got 0 to 5, and I've got the common connection. Excellent. Now, if we're looking at P&ID, we're looking at this silk screen on the top of the pumping unit. Looks like the water is coming from the pump out here, and it's going to be coming out of this tube right here. I want all the flow to come out of this tube. I do not want it to go back in the tank, so I'm going to close off HV2. HV2 is this guy right here, so as long as I have that guy perpendicular to this pipe right here, then I won't have any water coming out of right here. Looks like there's some Ebola or something sitting on that pipe. That's disgusting. Okay, so we're gonna put this guy at 90 degrees and block that, and all the water is going to be coming out of this tube right here. If we follow this guy up, then it is going up to a ball valve. At the moment I have the ball valve closed, and that tube is going to go up to the base of the tank. It doesn't matter which one you go into. The other connection at the base of the tank is going to go to another ball valve, which I have closed right now, and that guy is going to come back to the pumping unit. So that comes over here, back to this input right here, and it looks like from the silk screen it goes through HV1 and goes back into the tank. So I need HV1, so HV1 is this bad boy right here. I need this guy open. I know it's open because it's parallel to this pipe right here, and that will allow the water to come back into the tank. Okay, in addition to that, at the top of the tank, we're going to block off this guy. There is a tube at the base of the tank, and if you don't block that off, the water is going to come up here, and then it's going to start shooting out of this opening here. So make sure this is tight and make sure this is connected in. Okay, then we need this guy right here. This is our overflow pipe. So the other opening there comes down and it comes over here, and then I've connected it into either one of these connections. If you look at your pumping unit, then that connection right here goes to here, and you can see that now the top of the tank is now open to atmosphere. So that allows atmospheric pressure to go to the top of the tank. Excellent. Last thing we need to do is we need to make sure that HV3, so this is HV3 down here, and we want to make sure that it is in the upright position. If it's in the upright position, then all of the water from the tank is going to come down, move over to the pumping unit, and then recirculate. If it is in the other position, so the other position is like this, parallel to the floor, that would mean that we're just recirculating the water that's in our lines. Well, we don't have any water in our lines. We want to make use of our tank, so we're going to lift this guy up. Excellent. You can see here that my water level is a little bit too low. Somebody must have had an accident last class. So we're going to lift that water level up so we have a decent amount of water to work with for this lab.
Alright guys, so now we need to send a signal to the pump to get it rocking and rolling. So what we're going to do is we're going to come up here to this slider. We're going to move it halfway to get roughly 50% output, so 2.5 volts to the pumping unit. And you can see that that controller output has now increased there, right? So now we've got voltage going to the pump as a signal. We have a 0 to 5 signal. We're putting roughly 2.5 of that 5 volts to the pump. And we'll go back to the lab and we'll see that the level is now rising, and we're going to stop it when it gets to 50 centimeters.
Alright guys, so what I'll do is I'll turn my pump on. That 5 volt signal, or 2.5 volt signal I guess, because we're doing 50%, is now increasing the level in my tank. I'm going to close off both of these valves for 2 seconds, and that stops the level obviously from increasing. I'm going to open one, and that's my fill valve, and then I can get better control over this unit. I'm going to stop it right when it gets to 50. Beautiful. So now we're at 50. Right, you can use your valves to feather the water going into the tank and get it exactly at 50 centimeters.
Alright guys, so that motor's rocking at 53%. There's the output there. We're going to slow down the motor and use the valves to keep the level intact, right? Why have the motor running at 50% when we can use the valving right now to keep it at that appropriate level? Alright, so on your lab manual, we're now on step 4. We've brought the water level to its highest expected value of 50 centimeters. right? We've set up everything. We've looked at all of our HV1, HV2, HV3, right? We've opened our fill hand valve, closed the empty valve. We had it at 50%, and now we have our level sitting right here at 50 centimeters, okay? We're using the valving, right? It says right here, it's virtually impossible to maintain your tank level by adjusting the voltage to the pump. It's much easier to use the valves to fill and drain the tank. Okay, let's get on to calibrating this ultrasonic sensor now. Alright guys, so once you double click on the Synix View 3 on your computer's home screen, it should bring up this workspace. Now the ultrasonic sensor that we're working with is the model LVL100-232. So we're going to scroll over here to Workspace, click on Workspace, scroll down to LVL100 settings, and then when we click, you should have this come up. And it gives you a crude diagram of the ultrasonic sensor that we're going to be working with. Next thing we're going to do is we're going to click on the wiring. So this guy right here. So viewer configure the sensor's output and output status indicator functions. So we're going to click on this guy just to show the wiring of this bad boy. And you can see here that this is going to give a current source or current sink and a 0 to 10 volt DC output. So this guy is going to provide us either with 4 to 20 milliamps output or with 0 to 10 volts DC output. We're going to make use of the 4 to 20 during our lab. Okay, let's hit OK, and then we'll look at how to hook this guy up to our computer. So back to the lab now. Let's physically connect this ultrasonic sensor up to our computer. So first thing we need to do is ensure that the ultrasonic sensor cable is connected to our interface box. The interface number is 6545-00. That should be sitting on the back plate of your training system. Okay, so make sure this cable is securely connected to here. Next thing for step number 9, connect the USB to the RS-232 cable from the interface box to your computer's USB port. So you have an RS-232 to USB cable. You're going to connect the RS-232 connection here, and then obviously the USB connection goes into the front face of our computer. And then finally, we need to provide that sensor with 24 volts. So you're going to grab your power supply, whichever power supply is sitting on your desk there. We need a 24 volt power supply, DC, and you're going to bring 2 leads from that power supply up to your interface box and put the positive obviously on this side, the negative on this side, and we're ready to rock. Let's go back to the software. Okay, so now that we have connected the ultrasonic sensor up to the interface box, provided the interface box with 24 volts, and connected our computer now with the RS-232 to USB cable, which should be ready to rock and roll now. So let's go to sensor. So we're going to sensor now, guys. Then we're scrolling down to connect. Okay, it gives us all these different COM ports. Who knows which COM port that we're going to be using? So let's let the computer decide for us. Click all ports. Okay, once you have clicked all ports, then go to find the sensor. It's going to go out, tone, and excellent. It has found the LVL100 ultrasonic sensor. Hit OK, and now hit connect. Now at this point you can copy the sensor setup to the workplace, or we can keep going forwards and you can set things up. But most likely this was already set up from a previous lab. So let's take that sensor setup and bring it right to our workspace. Excellent. Okay, so now the sensor and our workspace kind of viewpoint here that we're looking at, our window, the workspace window, they're the same. And you can see here that there's an equal sign. So that means that both the workspace and the sensor have the same parameters. If at any point we change those parameters, you'll see that there's an X here between the two, and I'll show you how to change that in a little bit. But right now, we're now talking to our ultrasonic sensor. Okay, so you may find that your graph is sloped like this, or like this. I'll show you how to set it up in just a few seconds. Let's start off by doing our user preferences. So we're going to do Edit, User Preferences, and for our column of liquid, we're looking at centimeters. So I want you to next go to Distance Units, so right here. And if this doesn't have centimeters chosen yet, then click on centimeters so that it'll correspond to the units that we're actually using. Once you've done that, hit OK. If at any point I'm going too fast, hit pause on the video and scroll back a bit so you can replay what I've just told you what to do. Alright guys, next thing we're going to do is we're going to set up the low value endpoint for the ultrasonic sensor. The low value endpoint is going to correspond to our 50 centimeters, because at 50 centimeters, with our ultrasonic sensor mounted on the top, that's the lowest distance that we're going to see from this sensor to the top of the water column. So what we're going to do is, by clicking on Workspace, then whatever's in this window is telling you what's on your computer. If you click on Sensor, that tells you whatever is in the sensor's parameters. If they're equal, then they're both seeing the same thing. Right? But we want to change the values in the workspace, and we're going to change our low value endpoint. Well, right now I have the water sitting at 50 centimeters, and my ultrasonic sensor is giving out basically 10.9. So I'm going to go back to my workplace, then I'm going to click on low value endpoint, and for me, my lowest value is 10.9. Hit enter, and that will put that value into our workspace. Now as soon as I change that parameter, you'll notice that right here they're not equal. The workspace and the sensor are not equal now. Don't worry about that. Next thing we're going to do is we're going to set our high value endpoint. But first thing we need to do is drain the level in the tank down to 10 centimeters. Okay, so what I'm going to do is I'm going to open up my drain valve, and you can see that this value is changing right away. So we're draining out, and I'm going to stop it from draining by closing the valve when it gets closer to 10 centimeters. So we'll wait for a few seconds. Let me pause the video as it goes down so we don't have to watch paint. Okay, I'm getting closer and closer to my 10 centimeters now. And right there is my 10 centimeters in my tank. So now what we're going to do is we're going to set up our high value endpoint. So let's take a look at the value that the sensor is giving out. The sensor is giving us 50.7576 for our high value endpoint. So let's go back to the workspace, 50.75. And now we're going to punch in our high value endpoint. And for us, that was 50.75. Excellent. Okay, so now we have our low and our high points for our different levels in the tank. And at this point, it's screaming at us at the top that the workspace and the sensor are not seeing the same parameters. So what we're going to do is we're going to click on, I believe, let's see, workspace? No, sensor. Click on sensor. And we want to move our workspace that we've been working on over to the sensor. So you can see that it's now making them equal. So whatever parameters I had in my workspace window, the sensor now has the exact same parameters as well. Now if we left it like this, then everything would work backwards from the way that we're usually doing our setup. So what I want you to do now is to click on either the high or the low endpoint. Oh, it says I can only edit it in the workspace. All right, well, let's go back to the workspace window. Let's click on, let's see, right click on my endpoint. And it says, do you wish to invert the slope of the endpoints? Yes. Excellent. Okay, so now that corresponds to the way that we're going to set up the lab. So now we're set up so that when the tank is at its highest level, then it's going to give us 10.9 centimeters. And then when it's at the lowest level, it's going to give us 50 centimeters from the front face of our ultrasonic sensor. And we were able to see how to invert the slope of this graph here in case we were getting the opposite output from what we needed for our lab. So next thing we need to do is we're going to increase the level in the tank to 30 centimeters. So let me pause for 2 seconds. I'm going to start my pump back up, and then I'm going to increase the level of the tank up to 30 centimeters. Okay, you should be able to hear the pump in the background here. So now I'm going to open up my fill valve, and I'm slowly increasing the level in my tank up to 30. I'm going to use the fill valve to back it off and slowly feather it until I get to 30 centimeters. Excellent. So how accurate is this bad boy? Well, let's take a look right here. I just feathered that fill valve to stop me at 30 centimeters, and I'm getting exactly that value here on the screen. Okay? If you're getting to be like me and you can't really see that number because you're getting old, then why don't we go over here and hit this large display icon. Yes. And so that one's going to give us our milliamp output that corresponds to that value. Okay, so right now we're at 30 centimeters, and we should be getting half of our 4 to 20 milliamp signal, and we're getting 12 for our output. Again, if the 12 milliamps is screwing you up, remember that we have a 4 to 20 milliamp signal. There are 16 equal values between 4 and 20. If we take half of 16, we get 8, but that range is starting at 4. So 8 plus 4 gives us the 12 milliamps for our 50%. 50% from 10 to 50 centimeters is 30 centimeters. So we are bang on, right? It says 30.7. That's probably just because my eyes are going and I can't see exactly that the tank is at 30 centimeters. Okay, so this thing's deadly accurate, right? At our midpoint, we're getting 12 milliamps. Excellent. So now that we're all calibrated, then what I want to do is just scroll down to the bottom of the page here, and I want you to bring it back down to 10 centimeters, see what current output you have, increase to 10%, 25, 50, 75, 90, and then 100% of our 10 to 50 centimeters. I want you to calculate what you think you're going to see at each of those values, and then give me your actual meter reading of current that is being pumped out. Now the meter reading is coming right from this guy right here, right? So this value right here is going to provide us with our metering. We can also take an ammeter and confirm that as well. So grab your instructor, bring them over, and we can show you how to show you exactly how to take that current reading without blowing the fuse. And finally, once you've found each of those values from the graph above, or from the table above, then I want you guys to plot these guys out, and you should find that it's a linear increase from 10 to 50 centimeters, and that linear increase should be from the 4 to 20 milliamps right across. So you should get a nice straight line going from 10 to 50 centimeters and corresponding to our 4 to 20 milliamp signal out. Excellent. All right, guys, that's the end of this lab. If you're in the advanced group, you're just getting started. Now we've calibrated the ultrasonic sensor. We need to put in our parameters now for proportional, integral, and derivative, and set up a closed loop with this bad boy. So check out the ultrasonic level sensor video number 2, and that will help you to set up your PIDs for this lab. Thanks, guys.